Hi, my name is Chris McHenry. I am a technical solutions architect with Cisco, focusing on Cisco Tetration Analytics. Today we're going to take a look at one of the interesting ways that we can use the policy that is automatically created by Tetration to help us in an environment that we need to secure more effectively. In this case, we're actually going to be taking a look at Amazon Web Services. Tetration Analytics is designed to, without any input from the user, automatically discover the details behind how your applications are communicating with each other. We call this process application dependency mapping, and there are a number of different use cases for it. One of the primary use cases is helping us build out whitelist policy models and microsegmentation inside of our data centers. This is actually extremely important, especially in a place like Amazon, because Amazon follows what they call a shared security model, which means that AWS is responsible for the security of the infrastructure, the security of the physical locations of the data centers, and the users and consumers of AWS are responsible for the security policy that is wrapped around their applications. In AWS specifically, there's a tool called the security group, which is essentially a way for us to build a whitelist policy model or an access list, and it is required every time that you configure an Amazon Compute instance that you assign an appropriate security group to go along with it. Now, oftentimes, we can create a security group that's relatively wide open, but in order to be the most secure, we really would like to have a whitelist policy model associated with it. So in this scenario, I've got an application. It's based on WordPress, but it's a little bit more advanced than that, in that we have a load balancing tier. We actually have a database cluster. We've got a proxy and a caching tier. And several of these instances are actually deployed in an Amazon VPC. So we're going to take a look at this. If you see, Tetration has automatically grouped a number of these different instances into clusters. So it's looked at the endpoints that we have, it's automatically identified the IP addresses, and it's pulled those in and said, these are going to have a similar policy. If we want to take a look at all of the neighbors that it has, or the places that it needs to communicate with, Tetration's identified that too, as well as all the ports that need to be open. For this scenario and for this demonstration, we're going to focus primarily on the relationship between the database cluster and the HA proxy tier. If I look at this specific policy, you'll see that in order for this application to function, the HA proxy tier needs to be able to communicate to the database tier over port 3306. Now, within this workspace and within Tetration, we can always take this policy and export it in a standard format. So that's what we've done here. We actually have already exported it leveraging JSON, and you can see that the way the policy is built allows us to leverage this in a standard format to be imported in a number of different places. In fact, we have an open source toolkit called the ACI Toolkit that already has a built-in process for importing this particular policy into Cisco ACI. Today we're going to take that and build on some of the foundations of that to actually import into Amazon. And just as an example, you can see the format here is standard JSON, right? You can see information about the clusters, as well as information about the policies themselves, the port numbers, etc. So let's take a look at our AWS environment. In here you can see I have a number of EC2 instances that match to the policies and the clusters that we've built out inside of our WordPress application. You can also see that we have a couple security groups built. We have a default security group, and this comes with the VPC by default, allows all communication inbound and outbound and all communication within the VPC itself. I've also added a security group for SSH that when we are in our demo, we don't actually lose connectivity to the boxes that we're on. You can see all of the instances that we have currently are inside of the default security groups. So let's take a look at what that means for us. So in this environment, on the left-hand side, this is my database server. On the right-hand side, this is my HA proxy server. This is the relationship that we're looking at that needs to have access to MySQL on there. So just to take a look at this, if you, we can log into to MySQL on this box. You can see it is actually running the MySQL database. You can also see on this side we do have access to get to that box as well. So I'm actually going to access it in a couple different ways. First off, I can ping the box. So we'll look at pinging 172.31.21.183. And this makes sense because the default security group has allowed us to access these two boxes over any port. I also have kind of an illicit web server running on this box as well. So if we curl that same IP address, you'll see a response from Nginx in that environment. But let's start the ping back up. So what we're going to do now is we're going to run a script. This, like I said, borrows some code from the Cisco ACI toolkit. It also leverages the Amazon Web Services Python library to take that JSON input and automatically import the data into the security groups and then reassign the EC2 instances. So what we'll do is we'll run our script. As this is importing policy, what you'll see is that relatively soon our pings are going to die because it's gone in and it's taken that particular virtual machine and it's actually reassigned it. So you can see we've stopped at sequence number 34. If I go back over into the AWS security group scene, you'll actually see now that we have a number of security groups that have been created that match specifically to the environment that we're looking at. So just as an example, if I look at this database security group, you can see between this group HA proxy, the database is allowing inbound port 3306, but we don't have many other ports that are allowed. This policy is what has been auto-discovered by Tetration, and so it's based on actual real-world traffic and the way that we have retroactively reverse-engineered the policy for this particular application. You can also see when we go over into the instances that we've automatically categorized and added the security groups these particular instances. So if I go back over here, we'll quit our ping now. You can see that that died, but just to give a couple other examples, we'll go back and we'll redo our curl, and that's no longer going to be responsive. But what's interesting is, let's say that we want to actually go back in and look at logging in via MySQL. That's still going to work for us. So all of the code that you've seen here is available on GitHub. And if you're going to use this in a real-world environment, you'd probably want to tweak it a little bit. In this scenario, we have extra clusters, things that are connecting back into our internal data center, and you probably want to put a little bit of intelligence around that. But this is just an example of how standards-based policy that's discovered by Tetration can be used to be imported into a number of different circumstances. Thank you very much.